So the properties of logarithms, I'll go through and explain all of them. Anytime the base of the log and the thing next to it are the same, the answer is going to be 1. Whenever those are the same number, the answer is 1. They cancel each other out, basically. The reason is because logs ask base to what power equals this thing. So it's saying b to what power equals b. That's why it's 1. That's what logs ask. Base to what power equals that thing. So you could apply that same kind of logic here, saying the base to what power, well, actually it's not telling you what power, it's saying power 1, or power 0, I mean, equals 1. So no matter what the base is, it's saying what power would make it equal 1, and the answer is always 0, because anything to the 0 power equals 1. These three rules right here, 2, 3, and 4, these are for what's called either expanding or condensing logs. Expanding or condensing, because you can expand multiplication to the addition of two different logs. Multiplication goes to addition. Similarly, division goes to subtraction. And then slightly different is you can take the exponent and move it to the front. So you get n times log base b of p. Or same thing here, if it's natural log, take the exponent, move it to the front. So exponents can go to the front of logs. Division is subtraction, multiplication is addition. And you can do those backwards too. Subtraction goes to division, addition goes to multiplication, or a number in front of a log is the exponent, which depends on which way you're manipulating the equation. And whenever you've got the base with a log and an exponent, so if the log is in an exponent, if the bases are the same, the whole part just cancels out. You're just left with p in this case. Natural log is base e, so the bases are the same. They cancel out. You're left with p. So this first example, all of these come from the previous properties we were just talking about. But this first example is, remember, logs always ask base to what power? So it's saying 5 to what power equals 5? Obviously, that answer is 1. Whenever these two numbers are the same, cancels out just 1. Log base 7 of 1. So that's saying 7 to what power equals 1? That's got to be a 0. Anything to the 0 power is 1 all the time. So whenever there's a 1 next to your log, the answer is 0. Number 2 is all worked out for you. 6 can be written as 2 times 3. And then we had the property that said multiplication can be expanded with addition. And then log 15. 15, you could get that by doing something like 45 divided by 3. So division turns to a subtraction, so that's log 45 minus log 3. Just remember, if they don't have a base, it's always 10 on these. And they all, in the problem when you're working it out, they all have to have the same base. So if the base is 10, it's going to stay 10 throughout the whole thing. If it was base E, it would stay E throughout the whole thing. Natural log. And then we talked about exponents. You can move them to the front. So that goes 2 in front and then log 5. Or the 4 goes to the front, so it's 4 natural log 5. So we have logs and exponents are inverses. So this is 3 to the log base 3. The bases are the same, so they cancel out. You're just left with 9. E and natural log is base E. So the bases are the same. They cancel out. It's just 5. This last one's the same idea, but first you have to think of moving the number that's in front of the log to be the exponent. So you move the number in front of the log to be an exponent, so that's now 5 cubed. And then E and natural log cancel out because they are inverses. We're just left with 5 cubed, which is 125. So now we're going to simplify these. So that means we're going to take the addition and we're going to condense it to one logarithm. And addition condenses with multiplication. So you do 40 times 5 over 2. Forty times 5 is 200, divided by 2 is 100. And if you're not careful, you stop there, and you don't take the extra step to think about this and realize that this is saying log base 10, which means it's asking 10 to what power equals 100. So the final answer is just 2, because 10 squared is 100. It's kind of the same idea here. We're going to condense subtraction to be a division. So we're going to do log, keep the base, 9. And that's 25 divided by 75. Because subtraction condenses to division. And then 25 divided by 75 can reduce to 1/3. And this one's a little tricky, but that's saying 9 to what exponent is going to equal 1/3. So we know a negative exponent is going to make it turn into a fraction. So it's going to be negative something, because it's going to take that 9 and move it to the denominator. So then we need our numbers to take that 9 and make it a 3. So 9 to what exponent is just regular 3. That's 3 is the square root of 9. And as an exponent, that's 1/2. So it's the square root of 9 to the 1/2 power, and then it's negative to make it be in the denominator. Natural log E cubed minus natural log of E. First, exponents. Moving to the front. Natural log and E, those are inverses. It's 1. So that's 3 times 1 minus natural log of E, that's 1. So final answer is just 2. 1 minus 1 is 2. E and natural log, they're inverses. So E to the natural log is going to cancel out. We just get 3. E natural log cancel out. We just get 2. E, natural log, cancel out. We just get E. So these are pretty much the same steps. We're using those properties. We're going to write it as a single log. So our final answer is only going to say log and then a whole bunch of other stuff. But it's only going to have log one time. So we're going to take all of our numbers in front, the coefficients, whoa, and you're going to make those be exponents. So that's x to the third. And this would be y squared. And then we're going to condense those to be one logarithm. Addition would condense with multiplication. So that's x cubed times y squared. That's it. So we got natural log 5. We've got a number in front, becomes an exponent. If you didn't want to write 3 squared, you could have just wrote 9, because that's 3 squared. So these aren't that difficult, but this problem is one of the ones that students commonly make a mistake when you start condensing this. So we have natural log 5, and then minus goes to division. Subtraction goes with division, so that 9 goes on the bottom. And then the common mistake is that students think that that negative still has something to do with the last term, and it doesn't. The negative belonged to natural log 9. It had nothing to do with the 18. So that 18 is being added, which means it's multiplication back up top. The addition positive means it goes back up top. So then we need to work this out. We can reduce 9 and 18 is 2. So that's just natural log 10. So the coefficients in front of log are exponents. So that's a 3 over 5 as an exponent. So that's x to the 3/5. And y to the 2/3. Addition is going to get condensed to multiplication. And there's a couple ways you can do this. This isn't wrong written this way. It's the same as writing it. It's a 5th root of x cubed and the 3rd root of y squared. That's the same. Or to review something we did a long time ago, you could actually put those together as one radical. If you look at the denominators 3 and 15 and get a common denominator between your exponents. 3 and 5, common denominator would be 15. You can think of this as 9/15 and 10/15. So you could put those together as a 15th root. They both have the denominator of 15. and it will be x to the 9th and y to the 10th. This is my favorite look for the answer. It's most simplified, I think. So this has subtraction, log minus log, so we're going to condense that to be division. And then that's a problem from I think, Unit 3, where we factor to reduce that fraction. So factor, stuff cancels out. There's x minus 1. So these last couple examples are the exact reverse of what we just did. So now we're taking one log and we're going to write it out as multiple logarithms. So the first thing you need to do is realize that there's multiplication right there. So right where there's multiplication, you're going to expand that. Multiplication goes with addition. And then we have an exponent, which you can move to the front, make it the coefficient of the log. And that's as far as you can go. When you're expanding, you're looking for multiplication, division, and exponents to split. Don't get thrown off because there's addition here. You cannot split addition. You can split multiplication, division, and exponents. So we're looking for multiplication. We're looking for division. We have multiplication going here. So that's log base 5 of x squared. Plus log base 5 of the square root of y cubed. And now this is division, divided by z to the 5th. So that's subtract. And then the w to the 6th, that's still in the denominator, so that's still division, so we're subtracting again. You could also think about that since it's in the denominator, it's a negative exponent. Exponents go in the front, so that's why it's like a -1 in front. Denominator just means negative exponent. Exponents go in front. So speaking of exponents going to the front, let's do that. Remember that square roots are like fractions as exponents, so the square root will be the same as a exponent divided by 2. So we're going to move that 3 halves, the 3 over 2, to the front. Move the exponent to the front, so that's 5 log base 5 of z, and move that exponent to the front. So when there's no more multiplication or division, or exponents following the log, that means you're done. So it's just an x, it's just a y, just a z, and just a w. That means you're done. So we have a square root of two things being multiplied together. You can, before we jump into any log stuff, you can think of that as x squared plus 1, square root of x squared plus 1, times the square root of x minus 1. You can split those up. So we have multiplication between those square roots. Multiplication gets expanded with addition. And then divided by y to the fourth, so that's subtract. We still have exponents going on. You can think of square roots as 1/2 as an exponent, which means you can move the 1/2s to the front. There's no multiplication or division going on here, so we cannot split that anymore. 1/2 to the front. No multiplication or division going on there either, so that part's done. Move the exponent to the front. And it's just the y, no multiplication or division, so you're done there too.